This is shop talk. One missing line at the top of your program can turn a 10mm pocket into a 10-inch crater. That line is G20 versus G21, and it's the cheapest scrap in machining. G20 means inches. G21 means millimeters. That's the whole vocabulary. But what they actually do inside the controller is set the units for every coordinate that follows. Here's the catch. The controller doesn't ask. If you don't declare units, it uses whatever mode it was left in by the last program. That's where the 25x disaster lives. Think of it this way. The program says move to X 1.0. In G20, that's 1 inch. In G21, that's 1 millimeter. Same number, 25.4 times the distance. Imagine a metric part program loaded into a machine left in inch mode. Every move multiplies by 25.4. A 5mm rapid becomes a 5-inch plunge. The tool's at the workpiece before the controller even thinks about decelerating. Run it the other way and it's quieter, but just as wrong. An inch program in metric mode shrinks everything by 25.4. The tool air cuts above the part and you spend an hour wondering why your finish pass left full stock. Both directions are bad. One destroys a setup in half a second. The other destroys your schedule. The default isn't safe. The default is whatever the last guy left. Most shops assume their machine boots into a known state. It doesn't. Modal codes like G20 and G21 stick across programs, across power cycles on some controls, and across operators. If you didn't set it, you don't know it. The fix is one line. Declare units in your safety block. Every program, no exceptions. G21 for metric, G20 for inch, right next to G90 and G17. And this is the opinion most operators will push back on. Post-processor defaults are not a substitute for declaring units in the program itself. CAM software lies. Posts get edited. Header templates drift. The G code is the truth. Here's the decision tree. Before you hit cycle start, check the modal display. Does it show G20 or G21? Does it match your program's intent? If either answer is no, fix it before the spindle turns. On Fanuc, the modal group is on the position screen. On Haas, it's on the current commands page. On Siemens, check the channel status. Every control surfaces it. Most operators never look. There's one more trap. Offsets, tool length, work offsets, wear values. They're all stored in the controller's current unit system. Switch from G20 to G21 mid-shift and your offset table doesn't convert. It just reinterprets. A tool length of 4.0000 in inch mode becomes 4.000 millimeters in metric mode the instant you switch. That's a 96mm error on a single tool. The controller will happily drive it into the table. So the real rule is 2 parts. 1. Declare units in every program header. 2. Never switch unit modes inside a program. Pick the unit system at the top and stay there until M30. If the part is metric, the program is metric, the offsets are metric, the DRO is metric. Mixing units is how you turn a controller into a random number generator. If you've made it this far, you already program more carefully than most. Add G20 or G21 to your header template tonight, and you've eliminated an entire category of crash. Subscribe for more shop floor breakdowns like this.